This is CPM Precalculus Chapter 2, number 111. The sum of the areas for the 6 right endpoint rectangles of the function a of x is equal to the square root of 2x plus 1 on the interval of 1 is less than or equal to x is less than or equal to 4 is 0.5 times the quantity 2 plus 2.236 plus ... plus 3 equals to 7.579. Okay, so what that equation is telling us is, remember, the area between our curve a of x, so we're going to use a again here, but it's a different a, on the region 1 is less than or equal to x is less than or equal to 4, is approximately, here we go, 7.579. Okay? What does the 0.5 represent? Well, in this equation, right, when we're looking at rectangles, we know that we're finding the area is going to be of a rectangle, right? I can even write subrectangle. It's just the base times the height. And we know that if we're going to use 6 right endpoint rectangles, that means there's going to be 6 different heights, right? And the base is the same each time. So this 0.5 represents the base length of each rectangle, right? We can also test that because we know the width or the base of each rectangle is equal to b minus a over n. And over here we have the range is a and b as the endpoints. So b is 4, a is 1, and the number of rectangles is 6, so n is equal to 6. And that's equal to 4 minus 1 is 3 over 6 is 0.5. And so right now we know 0.5 represents the base length of each rectangle. Okay, let's go on to part B of the question. Part B says, let a different function called b of x equal to 2 plus a of x. Okay, remember a of x was our original function. Find the sum of the areas of the 6 right endpoint rectangles of b of x on that same region. Alright, so what we can use here is we can go ahead and use this function, right, and add. So b of x is our function plus 2, right? So this plus 2 here is just going to be 2 plus the square root of 2x plus 1, which is a of x, right? So because we know transformations, we know, right, b of x, let me write a little note here, I'm just going to write, is b of x is a of x, and when you add 2 to the function is a of x shifted up 2 units, right? So knowing that this is the transformation that is taking place, right? We can go ahead and look at this in terms of what's happening. So let's say we don't know what a of x looks like, okay? We have a graph here. We have a of x, maybe it looks like this, okay? This is just a of x. What we know b of x is going to look like then, right? B of x is just going to be adding 2 units to every point, right? So every point has to go up 2 units, every single point, because b of x is just a of x shifted up 2 units, right? So it looks the same, it's just rising a little taller, right? Because we know a of x is shifted up 2 units. Over here, this is b of x now after it's shifted up, okay? So given that, we know on the region 1 to 4 here, so let's say this is 1, this is 4, we have 6 right endpoint rectangles, so 2, 3, and each width we know is 0.5. we had a rectangle going up to here, right? We had one going here, we had one here, and so on. Like we had 6 right ones, and this is not even the picture of the exact picture. I'm just getting a rough idea. But now these are going to be going up higher, right? Instead of there, they're going to be going up here, right? Up here. And what is that additional height that's taking place? Well, it's exactly that height, the delta there, is plus 2 units, right? Just because we know b of x is equal to a of x plus the 2 units. So, given that information, we know that the area bounded by our function b of x between 1 and 4 is just going to be the same thing here as the area bounded by a of x, right? The area bounded by, and again, we're using 2a, so I'm kind of making this one italicized or crooked a little bit. The area bounded by a of x within this region, plus we're going to add in 2, right, times the base for every rectangle, right? We're adding in the height of 2, so it's plus 2 as the height times the base, remember, is 0.5 for every rectangle. And we could add this in 6 times, or we could just say multiply 1, 2, 3, 4, 5, 6. Multiply this number times 6. Okay? And so that's equal to, we know the area under the curve a of x between 1 and 4 was 7.579 plus, and now we're going to be multiplying by 2 is the height, 0.5 is the base of every rectangle, and we're doing that 6 times. Okay? Plus 2 times 0.5 times 6. Okay, so let's move down. We get some more room. 7.579 plus, right, order of operations. We're doing multiplication first. 2 times 0.5 is just 1. So that's just going to be 1 times 6 is just 6. Okay, so if we add 6 plus 7.579, and we get 13.579. So we didn't have to do anything else, and we could just see if we shift a of x 2 units to get b of x, we're just going to be adding a standard rectangle, right, of height 2 units, the same base, 0.5, to each of the existing rectangles, okay? And again, this is units squared, and let's box our answer. And that's part B of the problem, okay? So let's go on, because we're going to use the same thinking to do part C. So part C is asking us a similar question, right? We're given the same scenario as we did in part A and B, but now we want to find the sum of 6 right endpoint rectangles for C of x. And C of x is just defined to be 1000 plus A of x. Okay, so that's just A of x shifted up 1,000 units. Okay, so you could shift up any number of units. Because we have the same region, we know that we're just going to find the area bounded by C, and our region 1 is less than or equal to x is less than or equal to 4. And that's going to equal to our area bounded by our function a. So this is our function a. And 1 is less than or equal to x. It's less than or equal to 4. Plus, and we're going to add a rectangle with the height of 1,000, right? 1,000. The height of 1,000, right? The base, remember, was 0.5 for every rectangle. And we have 6 of these, right? We still have 6, just like we started with, okay? And we know this is equal to, they tell us this, 7.579. We want to add this quantity. Well, what's 0.5 times 1,000? You can use your calculator, but half of 1,000 is 500 times 6, right? 7.579 plus, well, 500 times 6. We know that is going to be 3,000 right? Because 5 times 6 is 30. And we add those together, we get 3,007.579. And again, our units for area is units squared. Box our answer. And we're done. Okay, so the thing to keep in mind is if you're just going to transform a function by shifting it up, that's going to create a uniform rectangle height of this is the new additional height, right, added to each subregion. All right. So this is something to keep in mind as you do transformations. If you know the area for one function between one specific region, you can now find it for another function that's just gone through a vertical translation of shifting up really quickly by adding in the base times the height times the number of rectangles. Okay, so this ends for us CPM Precalculus Chapter 2, number 111.